This is just a write-up I have made a few minutes ago.
Yes.
Whose heading is the structural design process in Prota structures according to Bromtech.
Yes.
And actually, when you want to register with the BK, whatever we are going to do today is not the first thing you do. When you're presenting a project APK, you have to first of all do manual load takedowns for your elements, so that you get the loading of your probably critical beam, loading of your critical column, footing and all that, and you design them manually. After you've designed the elements manually, now you feed them into a program again. You design, you model, so that you get the behavior of the whole structure. So from this class, what we are going to tackle is from the Prota structures bit. We leave out the manual calculations first. We do the Prota structures bit, and then once we are done with Prota, once you have understood to use the software, now we go back to those manual calculations. Yes, when we will also do the manual calculations when we will be doing Procon. That is why I realized hakuna haja nianze nayo sahi, and then later on it is going to, they have almost the same procedure.
Yeah. Okay.
Yeah. So the first thing you do once you get the architectural drawing, according to my step 1, is that you come up with a beam layout of all floors. And it's normally very easy when you have a flat where the floors are typical, because your layout is the same. So if you generate one layout, it means you multiply to the other floors. But if it is for a mansionette, you or the floors are not the same, you generate floor layouts for each floor. And what is going to guide your floor layout, your beam layout, is the location of your walls. Because you, on top of walls, what connects the walls and the slab is the beam. Yes, so the architectural drawing is supposed to guide you on that. And after you've done that, number 2 is you determine the location of columns in the structure and insert them in the beam layout. So again, if it is typical, it is very easy. But if the floors are different, sometimes you might even put a column on the ground floor. When you put the same column at the same location on the first floor, unapata it is inside the house. Maybe it's in or inside a room. Therefore, you have to restructure the position of that column. Therefore, these first 2 steps are important, so that you get your beams and your column positions. And, yes, these will also tell you your spans from the way you've spaced your columns. They will tell you the spans of your beams. And then after they've told you the spans of your beams, just a minute. After they've told you the spans of your beams, you can now go ahead and do there is something we call preliminary sizing, which is step number 3. Carry out a preliminary sizing of your members depending on spans and loading. So once you've positioned your columns, and also this comes from experience, there are certain type of structures, certain columns cannot handle. For instance, if you have a structure that is, let's say you're designing a market that is 5 floors, and you want to use a column of 200 by 200.
It cannot happen.
Yes, and the building is entirely framed. That is not merely practical, because that column will fail.
It is not practical.
Yes, unless you do something special to it. You can decide to make it a composite column. You do an I-beam and you encase it with concrete. But again, those are extreme engineering. For these simple structures, experience and loadings and all that will guide you on the size, the member sizes. After you've determined the preliminary sizing of the members, does not mean that is the final size. Sometimes you will design, the member will fail, and then you have to
go back and change.
Yes, the size of that member. On step number 4 is now you model the structure in Prota structure. And once you model, you start with grid work, because the grid work is what will tell you the position of your elements. And then you model columns first, you go to beams, and then you go to slabs. And then if they're typical, you can multiply that floor you've modeled and loaded it to the other floor. If they are not typical, it means you have to model each floor. And once you have modeled, you of course analyze to get your moments and forces, and then you design. After that, you do not entirely trust that whatever result the software has given you is final. You need to go back and either carry out manual design of one or two elements to confirm, or use another software so that you can find out. Sorry? Wow, I'm having an echo. Wow.
Oh, that is okay. I'm saying using the laptop. Let me do. That's okay now.
Yes.
I want to now remove from the sim now to laptop.
Good.
Mm.
Yes. After you've done that, you use any other software to try and check whether what you have designed in Prota structures is the right thing.
Okay.
Yes. And then once you've designed, you go ahead and generate working drawings. Those ones you can use using any software you are conversant with. You can use KiCad, AutoCAD, Procon, CSI Detail, Revit, and the many others.
Okay.
Yes. And then, of course, once you have detailed, you now come and generate design calculations from the softwares that you've used. You can get, like, Prota Structures gives out very good designs of columns, beams, pad footings, raft. Yes, it also does slabs and all that. So I normally love you detail first and then you generate design calculations, because when detailing, there are things that you might change one or two, and then you will note them somewhere, so that when you're generating design calculations, they need to match the detail that you have provided. But that does not mean.
There is something that I'm not getting,
Yes.
From Prota to Procon. Can you just repeat the statement?
I said once you have modeled and designed something in one software, it is good you either carry out manual design of the elements to confirm whether that software is okay.
Oh, okay.
Because it is basically garbage in, garbage out.
Yeah.
So if you know any other software, kama Procon, you can feed your data into Procon and design an element, and then you compare the two.
Okay.
Or you can design it manually to find out whether it's okay.
Okay.
And then you generate working drawings and design. I was saying now, when I was talking about design calculations, that you generate working drawings first, and then you generate design calculations. Because once you are generating working drawings, there are a few things you might alter here and there. For instance, you might have a beam that the spacing of the links is 150, at a certain location it is 200, and the beam is 380. So when detailing, you might decide to use the minimum, which is maybe 150, to detail the entire beam. Yes. Now, after you've done that, it's when you will come back to the design calculations, you change that before you generate that.
Okay.
Yes. Though there are different ways you can go about this, but always ensure that your working drawings and your design calculations are marrying, and and you do not alter anything from the design.
Mm.
Yes. So after that, you might go ahead and produce bar bending schedules. Actually, in Prota you can, or even in Procon, you can produce this using the two software. And then, depending on the job description, you can also take a quantity takeoff. But this is majorly by the quantity surveyor.
Okay.
Yes, once you've done all that, you're done. Process number 8 is now you print all drawings, calculations, schedules, takeoffs, and everything that you've done in PDF and submit to the client or to whoever is responsible.
Okay.
Yeah, so basically this is what I follow, and now I'm going to get the drawing that we will use today. This is I'm using ArchiCAD because this ArchiCAD file has the architectural drawing that we will use, and I have prepared a
Mm.
few other drawings to explain what we will do today. Number one, this was the architectural drawing. It's slightly big, so you might not see everything, including the dimensions. But
No point of dimension. It is clear. I can see what is there.
yes, so this was a commercial structure, and you can see we have shops, and this is open, and we have toilets and the staircase here. From
Mm.
observation, you can also realize this is the ground floor because it has the septic tank and the soak pit, so it means it's the ground floor. And
Mm.
this line here, this line you're seeing is the property boundary. So on this side it is on the boundary, on this side is on the boundary, but there is this space in front and these are the back, and there is an open space at the center here. Why am
Mm.
I showing these boundaries? Once you want to start designing, you need to know where your structure is sitting so that you know whether there are axially loaded footings in your buildings or
Mm.
any other special considerations. Therefore, when you look at these footings are okay, they are within the boundary, and there is even enough space to extend the footings outside and this side also. But when you come to this elevation 21 from this drawing, when you come to this elevation and this elevation, you see the building is at the property boundary.
Mm.
Therefore, it means your pad footings will be eccentrically loaded.
Mm.
Now, this is the ground floor plan, and you need to read it in conjunction with the site plan. This was the site plan with the under high bridge, and then this is a 6-meter access road, and you can see our structure, the way it is sitting. So once you interpret that correctly, you now move to the first floor, because you cannot generate a beam layout for the first floor if you do not know whether your building has balconies or any other changes on the first floor.
Mm.
So I don't know whether this first floor has, this one does not have a drawing. Let me see. Yeah, first floor drawing is here. So you can see we still have the shops the same way they were in the ground floor.
Mm.
And then we have balconies extending to the front side.
Mm.
Yes. But actually this drawing is different from the one we had, because you realize the other one we had, this was not at 90 degrees. The line was skewed at 6 degrees, and this line was
It
also
was
skewed.
skewed.
Yes.
Mm.
So initially we had drawn this, and then we changed it to make it skewed so that we fit it into the site plan, because of the shape of the land.
Okay.
So, and something to also note, the only consideration we are taking here is that we have a balcony at this point,
Mm.
And then we have a balcony just next to the staircase, which is starting there and it is going all the way to the front side. And also this side is covered by a slab and this side is covered by a slab just by the show of these grills. Yeah. So let's go back to the ground floor. Where is it? Yes, it's here.
No, this is Akikande.
Yes, this is ArchiCAD.
Yeah, I can see.
I'm using it because it is the one with architectural drawing so that we can easily follow.
I'm wondering, and it is not. Oh, it is not affected by the online.
No.
By the
No,
whatever.
nothing is
Huh?
affecting my software.
Well, okay.
Yeah. So let's go to, this is the architectural. Let's go to step number 1. Step number 1 was saying get the architectural drawing and come up with beam layout of all floors.
Yeah.
Yes. So it is good practice that to come up with the beam layout of the first floor, you use the floor layout of the ground floor because those walls are the ones that will have beams that will carry the slab. So you are supposed to get the ground floor, find out the beams that can exist from the walls existing. For instance, I know I have a beam here, I have a beam here, I have a beam here, right here, and because these walls are here, I will have a beam that will carry the slab on top of it. And then you go to the, after you have done that, you generate something like this. This is what I was talking about. This is basically the beam layout. And I have even, after I generated the beams, I decided to position my columns now. Yes. So I was guided by the ground floor, but after I have drawn the ground floor, you realize the ground floor cannot show me the balconies that exist.
Yes.
Yes, that is when now I took my drawing to the first floor and found out which disparities exist in my drawing. I realized I had a balcony here, so I had to extend this to make the balcony. And I had to make these beams to behave as cantilevers. I also did the same. You remember we had the cantilevered slab starting right next to the staircase, and that is what I did here. And it is being carried by the cantilevered beams from the structure all the way up to this side. Yes, and then this was a void, and then there was another void in front here and in front here, but those do not affect our drawings. So this is step number 1. Yes, you just find a way of eliminating all walls, ensuring you have beams on top of your walls. And then you go to the first floor, you find out, do I have any other wall that is going to load my slab in a way that it will need a beam? You either add the beam or you design the slab to carry that wall. Yes. After doing this, the next thing that I ask myself is, I need to do a preliminary design of my structure. How many floors is my building? I don't know whether this can show me the 3D. Let's see whether it can open the 3D or the 3D is not. So you see, I had my ground floor, and then first, second, third, fourth, and roof. Yes. And from the architect, he might not give you this 3D. So what will help you identify these are the elevations. Let's open an elevation. here we have an elevation. This was the west elevation. What my elevations are going to help me is to determine the level or the height of the floor. And that one must be clearly indicated by the architectural drawing. So you realize that ground floor is at 0.00 and the first story is at 4.6. That means my floor to floor height is
This 4.5.
4.6.
Oh, 4.6.
4.6.
4.6.
Yes.
It's too high.
Yes. And then the first floor is 4.6 to 7.6. That is 3 meters.
3.
And then this is 7.6 to 10.6, 3, 10.6 to 13.6, this is 4, 3 still, 13 to 16, 3,
3.
and then 16 to 19, this is 3. So all floors are 3 meters floor to floor, but the ground floor is 4.6 meters. Let me get another elevator. Let me get another. So that we see whether I want to explain the 4.6. This was a commercial building, so the ground floor was a bit higher. It was the ground floor was like a bank or a hardware, so it requires a lot of space. I don't think this is going to explain what I want.
I can understand what you're saying.
Yes. It's a bit slow, so I think we can just proceed.
See, I'm trying to close one of the on this turn off.
This will load forever. So let's just proceed. I hope you're connected because the echo is back. I don't know.
I want to close this one from my phone.
Okay. Right here. Yes, it's here. So you realize that the ground floor had these were the doors.
Yes.
And then it has a beam and it has a window. This is like a louver, or you can do a louver blocks here, and then you have the main beam. Yes. So here you design the main beams first, and then these small beams you will design them later, because they are just the only weight they are supporting is at the where the door is. Yes, but the beams that are carrying the building are the main beams here. So these ones can be designed later that you design the main ones. So I think that explains almost all that I wanted from that section.
Okay.
Next, after you've determined your levels and your heights, that will help you do a preliminary size of your columns. Because this is a commercial building, it is almost 5 stories high. I did 400 by 300 columns.
Before we proceed,
yes.
Now these are beams, the beams that we normally use from the architectural drawings. These are beams.
Yes.
They are not walls, they are beams.
Yes.
Okay, let's continue.
Yes. I'm designing my structure as frame.
I understand, yes.
So yes, but the reason why I was using the walls is because of architectural aesthetics. And because we have the junction between a wall and the slab, that junction we are supposed to put a beam there. Whether the wall is distributing our load or not, it is good aesthetically to play, because it will not make sense to have a beam inside the room. And then at the junction where I'm having the wall, there is no beam. Yes. So that is why we use walls. We use walls of the lower floor to get beams of the floor above.
The floor above.
Yes. But after we have gotten those beams, we how do we call it? We superimpose them on that floor that is above to find out whether we need to add.
Nikupigie, niko online niko online meeting niko online meeting ndĩrauga ndĩ online meeting ui thaa ici ngiri na matano ma ningũkwethera ngiri tũthetamba ndagĩka 20 tũrĩkie mũcemanio ũyũ please. Nitakuwa najua, wacha tukiendelea, nimemute kidogo, nitajua vile tutafanya. Sawa. Endelea.
Yes, that is what I was saying.
Yes.
We after you have gotten those beams, you still superimpose the floor above to find out whether it has any walls that are very heavy or any big spans that might require additional beams. Those are the ones that now can run inside the rooms and maybe cantilevers if it is allowed. Yes. And then I have talked about sizing of the columns. These columns I've just assumed based on my experience because of the height and the spans. And since I have spans of this is 6 meters, therefore that tells me my beam is going to be either 500 meter deep or 600 meter deep. So I'm going to adopt a beam of 600 millimeter deep beam and columns of 300 by 400. And then, yes, those are the main things you're going to do your preliminary design. For footings, you don't preliminary design them. You design them after you've loaded the structure. And then once I've done that, now I need to generate my axis, grid lines. Because grid lines are the ones that are going to guide me to model the structure in Prota.
So all this work you are doing on your architectural drawing.
Yes.
Okay.
Yes. And when I'm doing this work,
yes,
I have not yet started designing.
Sorry, you have not started designing?
Yes, I'm just preparing to design.
Can you do it on structural drawing?
Structural drawing, but
it may be difficult now to put the beams.
To get the beams.
But the column,
yes.
The structural drawing, the AutoCAD, that is.
Oh, I do the same.
Whatever that we are doing,
yes,
we do it on AutoCAD.
Yes, you can do it on AutoCAD.
Maybe in AutoCAD there will be a problem of putting the beams. I've never checked on putting the beam on AutoCAD.
Actually, what you can do, the same way I've drawn this structure like this.
Yes.
I can save it in DWG. And I open it in AutoCAD, and it will appear exactly the same as it is here.
Okay.
Yes. So you don't have to. You can do either the same, even the architectural. If you don't know how to use ArchiCAD, wow, the echo is back. I don't know why.
Yes, so yes, we got to continue. Somebody is disturbing me here.
Okay.
Tuendelee.
Yes. So this architectural drawing, actually, you can also feed it into AutoCAD and do whatever exact same thing you've done here. You can do it in AutoCAD.
Yes, yes.
By saving this in DWG, I think it has provision for that.
Mm.
You can either do DXF or the DWG is here.
Mm.
Yes, so it can. So it depends with what you are conversant with. But I'm using ArchiCAD because it has all of them here so that we can see the process.
Mm-hmm.
Actually, some people even do Procon.
Mm.
Some people detail this in Procon. So
Okay.
yes. So once I have preliminary designed, I was saying that this is not design. I am preparing to design. What I'm doing is
Mm.
generating layouts.
Yeah.
There are instances where I will even generate such layouts, and then when I'm designing this beam, I realize that it needs a lot of reinforcement, that I will
Mm.
increase its size. I will maybe make it 600 deep by 400 wide millimeters.
Mm.
Yes. So that will be at the design stage. For now, I'm just doing my preliminary preparations.
Mm.
Yes. After I have generated this, the next thing I said is to generate grid lines, as they
Mm.
can be shown in this drawing here.
Mm.
Yes. For grid lines, you can decide either they run at the face of at the outside face of your walls or beams. In this case, we are talking about beams,
Mm.
or they can run at the center.
Mm.
Yes. But I normally prefer when they are running at the center
Mm.
so that
Mm.
you can easily place your elements.
Mm.
Yes. So you realize I have my grid lines, there they are, and I have dimensioned them properly,
Mm.
both X and Y. And then also the skewed one, I have skewed it. Then I have placed the angle.
Mm.
Yes. So this was how do we call it? This was strip footing in preparation, but it is not yet complete because it does not have pad footings. This is a foundation layout.
Mm.
Yes, but once we will complete, you will see how the pad footing will appear. So yeah, after you've gotten your beams, you do the grid lines and then you dimension them. Whether you use
Mm.
AutoCAD or it's the same thing as long as you know how to do the procedure.
Mm.
Yes. Now from here is where we now start the technical bit of using Prota.
Mm.
Yes. After I have my grid lines and I have the dimensions of my grid lines, I now open Prota structures. I had actually modeled this structure and I want to show you how the 3D looks like. And you actually compare whether it is the same 3D you saw in ArchiCAD. Here is the drawing.
It is the one.
Yes. So there are a few things that are in the other drawing that are not here. For
The
instance,
idea, I've seen the idea is now to do the model.
sorry?
The idea is to do the model. That is the most important part.
Yes, yes.
Once you are done with the model, I think the rest will be, those other things will be very easy now to find on your whatever, and generated calculation or whatever, the drawings.
Yes. But now you see, this one is not entirely the same as the other one because it did not have the bit around the staircase was raised one more floor to carry the water tanks.
Mm.
But here, I have not yet done that. I had actually not finished this work.
Okay.
Yes, I need to add that. Ground, first, second, third. Yeah, I need to remove this floor and then leave this section for water tanks only remaining.
Okay. You
Then
remove the columns and the.
and the slabs and the beams.
Mm.
And then you also realize I have ribbed beams in all my internal floors.
No, they are
Yes,
really.
ribbed slabs.
Mm.
And then The topmost slab is
solid.
solid slab, yes. And we will explain all that when we get there. Also, another thing to note, we had a staircase here. And you have realized I have not placed a staircase. I have placed a one-way spanning solid slab, a ribbed slab. But I will show you how to put the staircase. This is still work in progress. So I want to close this drawing, then we start again. It is saving the project. So for today, our main aim is to place grid lines and place columns, because I'm seeing we will not achieve what we wanted. We will just do grid lines, all grid lines, and then place a few columns. It is saving. Yeah. So the first thing you do to open the software, it's right here on the desktop. Double click. I'm waiting for it to load.
As it waits for the program to go, let me try to prove one of these programs. Yeah?
Try
The
to
one
open.
that is giving us that headache.
So once it opens, this is what you will see. It is still loading. And all these are grayed out because we have not selected a project yet. So if it is a project you are working on,
Yes.
you look for it here.
You?
You look for it along these projects that are here.
Okay.
Yes.
These are the saved projects now.
Yes. These are the most recent. Like there is this one Karen, there is Obama Church, December Road, Edward Mwangi, Mogotio. These are the most recent, and you can see all of them have been opened in 2024 February. And but if you don't have any, if you are not seeing a project here, you go to open project, and then once it opens these, you have more projects here now. These are now all the projects that exist. We have William Ruiru with 80 flats, Dogoto, TBT, and all those. Yeah, so if you get it here, you click open, and then it opens, and you press OK and proceed. But because we are opening a new file, we are going to cancel, and then we go to new project. Once you open new project, on project code you enter the name of the project you're working on. So let's call this training 1. Also, there are things to note. On the project code, you cannot put space on a letter, on a word. Yes, you can, whatever you type is as a block. So you either use underscore or you do your words that are joined together. And then once you have your project code is basically the name of the project. You now identify the codes that you are going to use. And from observation, you have the Brazil, Hong Kong, and probably here we use the UK. So you are going to either use UK British Standard 8110 or the Euro code.
Let's use wheel code.
You want us to use Eurocoder?
The one that we are used to.
Well,
We are used to wheel code.
with me, I'm used to British standard, but I'm going to use this one.
Okay.
Yes. So you select there. Though you can change these later, but you can start by selecting there, and then you ensure your project code is okay. And then you press OK. And it is going to open your drawing.
Your page.
Your page. Sorry. Yeah. Once it opens this and you see this is not grayed out, then you are good to go. You can start working. So the first thing you do is you go to stories. First of all, you go back to the number of floors you had so that you find out how many floors you had. Therefore, this is you start counting from the ground floor. This is floor number 1, 2, 3, 4, 5. Then I'm going to have 6. This extra floor here. So this is 1, 2, 3, 4, 5, 6.
Oh, there are 7.
No,
Because of the water tank.
no. What you count
Mm.
are the suspended slabs only.
I'm saying, what about the one for the water tank?
That is why I'm saying you count only suspended floors.
Okay.
So you assume that your ground floor is not loading your columns.
Mm-hmm.
But in case where you're having a foundation that is, we can call it a floating one where you've tied your beams on the ground floor and the slabs are loading your beams,
You also consider that one.
and then you also consider that. But in this case, you just count suspended slabs only. That is 1, 2, 3, 4, 5, 6.
Okay.
So you come to story operations, and then you go to insert story. And then total number of stories, you enter the total number of stories as 6.
6.
And then you press OK. You realize this will take you to the floor number 6.
Mm-hmm.
So you take it back to floor number 1. We model in floor number 1.
Mm-hmm.
Yes, if you model where it's still in floor number 6, it will model it as floor number 6. So you have to ensure it is floor number 1. And then floor number 0, story 0 is the foundation. So that one
You don't need to model.
yes, you will do your pan footings in story 0. But modeling of columns, beams, and all others, you do not do them. Yeah.
Mm-hmm.
Yes. After you've set your stories, you also come. We did insert story. Now the next thing is edit story. Edit story. All those stories you've inserted are here. You can decide to define stories as similar, but here you remember the ground floor. The height was
4.6.
4600 millimeters. So you change H, and then the rest were 3 meters floor to floor. Then of course you have your cumulative here. This means the total height of your structure is 19.6 meters.
Mm-hmm.
Then once you have ensured your height, floor to floor height is okay, and then you can assume a foundation depth. Let's assume 1500
Or
footing
2
is 40.
meters.
Sorry?
Or 2 meters.
Yes, depending on where you are building. You can even take it to 3.
Mm-hmm.
But the longer the foundation depth, the more slender
Mm-hmm.
your column will be.
The more slender.
Yes, because if you have a foundation that is 3 meters deep
Mm-hmm.
and your column is not tied on the ground floor,
Mm-hmm.
that means your column is free from 3 meters deep to first floor. And assuming the first
To
floor is
be
4.6.
9 point something.
So you are going to have a column that is 9 meters high.
Mm.
Yes. So the deeper the depth, the more you will consider how to handle the column. So
Mm.
sometimes it might call you even tie them at the foundation level with strap beams, or you tie them at the
Mm.
ground floor with ground beams.
Mm. Mhm.
Yes. So after that you press OK. Now we have said we have been started with story number 6, and we have edited story height and foundation depth. If you
Mhm.
had made a mistake and
You end it.
maybe you say you had more stories, you want to reduce
Mm.
them to be 5, you can go to remove story, and then you select the story you want to remove, and then you press OK, and it will go.
Mm. So you click the information part,
Yes.
information bullet. Yes. Oh, okay.
Or
You
you
click like that,
anywhere, anywhere,
then
and
you
then you
cancel.
yes, and then you no, you press OK.
Oh, you press OK.
Yes,
Okay. Because when you cancel, it is escaping now.
yes,
Okay. Mm, okay.
yes. So there are also two operations here: remove story, and delete story.
Mm.
For you to delete story, it means you're deleting all the elements that you had modeled in that story. But to
Mhm.
remove, it means you do away with it completely. It stops existing.
The one that you're going to select, that is.
Yes, yes.
Mm.
And then generate story, you will see how it will work. Select those others you will learn later as you proceed. There are also other things that you need to be knowing, but for today we will proceed. You also need to know how to handle materials.
Mhm.
Then, though these are things you can always change later when you are designing. Also, on settings, you can do your layers, colors. These are just things to do with the display and
Mm.
the user interface you're using. And then now, after you're done with stories, the next thing is normally remember we are in building setup. Huh?
Mm.
Yes, and to go well in Prota structures, we move from left to right. So once we will be
Mm.
done with building setup, we will do modeling. Once we are done, we will load. Once you're done
Mhm.
loading, you review your structure if there is
Mm.
anything to be reviewed. Once you've done that, you analyze, you design, and then you generate drawings and reports, and then you can import or integrate with BIM and all that. So we move from left to right, but we are still in
Mm.
step number 1.
Mhm.
That is why I wanted us to finish step number 1 so that next time we proceed from number 2. After we have done our stories, we go to modeling.
Mhm.
In modeling, the first thing you do is you do grid lines. That is your axis.
Mm.
You can either draw an individual axis or you can draw all your axes at the time. So I'm going to
Mhm.
draw one grid line. You click on grid and you get this, and then you have this. The second option where you have the third one where you have, and then we use the code dimension like extension length. I can say to 1000 millimeters. This is the length of the extension. And then, uh, sorry for the error. From there, I can draw my grid line.
Mhm.
You see, it is free.
Mm.
Now, to achieve 90 degrees, you press Control.
Shift.
No, you
Control.
press Control, and then you can draw it. There you have your grid line.
Mhm.
You can draw another one. And draw another one. You can even draw it at an angle.
Mm.
But you might rarely use this because this is very tedious and you will stay there forever. So let me select, then delete. The select is basically like AutoCAD. Once you select from left to right, you have to select everything for it to be selected. Yes, you want to delete, but from right to left, you select, delete. Yeah, so I have a free window. There is also something I want to show you. Once I have an existing axis, there are things I can do to it. If I want to rotate it, if I want to stretch it, I can select, right click and go to properties. Sorry, not properties. Select, right click, and you have all these things. If I want to change a few things, I can go to properties, but here I want to show you how to offset. Offset, once I've clicked offset, you see it is giving me an option of a second one. Now I press F2. And then it opens up that dialog, and then I can say 2000. Maybe I want them to space that 2000. Enter. And then I can either proceed with the 2000 by clicking, and I just move my cursor in front and then I click if they are equally spaced. Let me undo. Yes. If I want to move, I just select, and then I go to move, and then I move it wherever I want. If I want to make it longer, I right click still, and then I go to stretch, and then I drag it, can stretch it upwards, stretch it downwards, and so on and so forth. To rotate, I do that. Then you see, I can start there, then find my angle. Remember, there is a line which was skewed at 6%. So I can get my axis skewed, something like that. So that is how we deal with grid lines. Then, yeah, those are the main operations on grid lines. But now I want to do away with them. Now, how do I easily draw my grid lines if I want to save time? I use this orthogonal axis generator. You click, then you click inside your borders, it opens this. And then I go to my drawing. I had my drawing. It has grid lines. These are assuming this is the x-axis. I start feeding these dimensions. This is 3990. So direction 2 is the x-axis. Direction 1 is the y-axis. So I'm going to start feeding them here. That's 990. Comma, you separate them with a comma. 2115, comma, 2085, comma, 2615, comma, 1885.
1885.
Yes, comma, 2815, comma, 385, comma, 3800, comma, 515, 515, comma, 4085, if I'm not wrong, comma, and then 3636. You realize I am done with the axis spacings in the x direction, the axis extension length I do not change. Now what I can change is the axis labels. So I can come here. What is my label? My labels are numbers along that axis. Therefore, it must be a number. I maintain one. One is okay. Now I proceed to direction number 1, which is the y-axis. And let me find out the axis label. I think it is a letter. Yes, it starts with A. Then I also do the same. But in this case now, I start from bottom upwards. Some people start inputting the grid lines from here going downwards, but it will disturb you. So it is better you start from the bottom.
But it will?
It will alter the way the layout will appear. So it will disturb you. It will rotate the work. It will disturb you when you're doing model. It is always good you model the structure to be like the layout that you had generated earlier.
So we say this is the one with letters is y-axis or x.
The one with?
With letters.
No. For letters and numbers, you are the ones to decide where to put them.
It's so in our case,
Yes.
With numbers, the one with number, is it the y or x axis?
The one with numbers is the x-axis.
Is the x axis? Yes. Okay. Yes.
They run along the y-axis.
Mm-hmm.
They give you your grid lines, but once you are reading them, you read them along the x-axis.
Mm-hmm.
Yes. So, and they are normally direction 2. You start with them down here.
Okay.
Direction 1 is the y-axis. You can also do the opposite. You can interchange them, but they will disturb you when you do model.
Mm-hmm.
So we also do that for y-axis. Let's start. This is 6200, comma 800, 1500, comma 900, 3600, 3600. You realize that there were very few.
Mm-hmm.
There are around six grid lines. 1, 2, 3, 4, 5, 6. Yeah.
Mm-hmm.
So once you are sure everything is okay, don't alter anything. You press OK.
Mm-hmm.
And there you have your grid lines.
Mm-hmm.
To confirm whether your grid lines are correct, you find out whether they are the same number. This is 1, 2, 3 up to 12. Go to your drawing. Yes, they are getting to number 12.
And F.
And this one are A to F. A to F.
Mm-hmm.
Now, there is one more grid I have not placed.
Mm-hmm.
This grid that is 1A. 1A is the skewed one.
Mm-hmm.
Is the one that is slanting. So how?
Mm-hmm. Are they two?
Yes, at that point there are two grid lines. We have this grid line running vertically, grid number 1,
Mm-hmm.
and then we have a
On
1A.
top of the other, the right hand side.
Yes. So we have this, and we also have this.
Mm.
And also remember, I have 1, so I cannot rotate 1.
Mm-hmm.
Yes, I have to insert a new grid line and call it 1A.
Mm.
So here you can use whichever method that is easy. It is like the construction we used to use. Was it primary or where?
Mm.
You can locate a point and go through all procedures, but I'm going to show you how I do mine. for me, I determine
with the
when the,
angle.
sorry?
You are using the angle.
Yes, yes. But me, I'm not using the angle. I'm going to draw mine manually
Okay.
because the angle normally disturbs me. When you look at grid along grid F from my layout,
Mm-hmm.
this
Mm-hmm.
second grid line is running at the center of
The beam.
the beam, and then this grid is also running at the center of the column. So I need to
Mm-hmm.
find the distance from here to here.
Mm-hmm.
This is
Mm-hmm.
117.
Mm-hmm.
So I need to come up with a grid line that is at this point. I need to find this point.
Mm-hmm.
So what do I do? I go to number one, I click it. Remember, there is an option I talked about called offset.
Mm-hmm.
If you move, I will move the entire grid, but if I offset, I will move a copy of that. So I go offset, and then you see I'm offsetting to the left. Therefore, I press F2, and then I do
Mm-hmm.
minus. If I want it to be to the left, I have to do minus
117.
117. Then I do
Mm-hmm.
enter, escape.
Mm-hmm.
You realize it is
Mm-hmm.
just right next to this one.
Mm-hmm.
Yes, how do I hide it? I click, then I go to properties, and then I hide visibility code, and then I remove these box from here.
Mm-hmm.
Then I say update, close. So
Mm-hmm.
you realize I have a grid line at this point. I can see it,
And it
but
is.
it is not named so that it does not confuse
Mm-hmm.
me. And then I go to the other side. That is along grid A.
Mm-hmm.
When I go to along grid A, I also find this distance. That is 1395.
Mm-hmm.
So I still go back. I look for grid number. It was grade one, I believe.
Mm-hmm.
This one, yes. 1395. I look for grade one. And then I offset F2. I do positive now because I want
Mm-hmm.
it to the right. Enter. And then I hide the visibility, and then I hide this visibility code. Then I update and close. So you realize I also have it here.
Mm-hmm.
And this the previous one is existing. And therefore I can draw a fresh grid line. You remember it was crossing this junction here.
Mm-hmm.
And when you get down here, it also crosses this new one.
Mm-hmm.
Then I click. Therefore, I have
Then
drawn
we
the grid
explain.
line here. Now, because it is at the center of my structure, I elongate it. I think I showed you how stretch axis. Then I stretch it up. Then I still click stretch axis. Where is it? There I have my axis.
Mm-hmm.
Therefore, I'm going to repeat the same to this other side. This one now I'm going to do it quickly.
But you can, are they skewed in the same position or how?
The same, are they parallel? Is that
Yes, can you check whether they are parallel to each other?
they are not entirely parallel because once I generated
Yes.
my layout from architectural, I found this to be 97 degrees.
Mm-hmm.
And then I found this to be 96.
Mm-hmm.
So they are different of 1 degree. So
Mm-hmm.
even if it is small, actually because it is small, you can
We can
assume
assume.
they are parallel.
Mm-hmm. Mm-hmm.
And
So what it is,
offset.
we can do what? We can offset.
Yes, but remember we don't have the distance. So let me do the distance. I don't know how it will do. It is on a
Yes.
vertical
Yes.
distance, 28,167.
Mm.
Let's try offsetting it, we see. You realize it is offsetting it parallel.
Mm.
Therefore, I cannot
Offset.
offset using this dimension. I need to find the dimension in the slanting direction. Therefore, I need to get a perpendicular line, which is also going to be a lot of work for me.
Mm.
But let me also do the same here. I like doing things manually. That is why I'm doing this, so that I know I'm on the right track without making a mistake. So let me get the center. And then where is it? Measure. This is 88 millimeters. So I'm going to offset this by 88. F2, and then because it's to the right, I do 88. And then I go to properties, I hide its features so that it does not disturb me. And then I update and close. There it is. And then I go down here. This is 1568.
Negative. It is negative.
No, it's positive because it's to the right.
Oh, okay.
Yes.
Yeah, of course.
And then properties.
Read both of them, eh?
Sorry?
Both of them.
For this one,
No, the other one. Eh?
oh, for this one, both of them are to the right. They are positive.
Mm.
Then I can come up with a new grid again. I can go to modeling and then I set my grid. It was crossing here. Then I also do that. And then you see, because its feasibility is hidden, I want it to be shown. So I bring back that, and then I go update. Realize that it brings them back. And then I can stretch axis. I can still stretch in this direction. Yeah, there you go.
Mm-hmm.
So all our grid lines are as in the architect, the beam layout that we have created.
Mm.
Now the next thing to do is to do columns.
Mm-hmm.
So we finished building set out. Now we are at modeling. We are finished doing the grid lines. Now in these tools, you also move from left to right. So you have to do columns. If there are
Mm-hmm.
walls, you do them. And then if there are beams, you proceed like that to the till the end. So I select column, and then it opens this dialog window. And I need to change the dimensions of my column. So I can decide to do, we said 400 by 300.
Mm-hmm.
And then I can come and place it where now I have to do it in conjunction with my drawing. So you realize it is at the junction of the skewed grid line and A,
Mm-hmm.
right here.
Mm-hmm.
So you realize I have placed, but it has changed what I had instead. So to do it easily, you come here, then instead of choosing this, you click on this rectangle.
Mm-hmm.
It gives you a number of columns you can use. You can use a rectangular, circular, a plus, a T-shaped column, an L, an hollow section, and all that.
Mm-hmm.
And if yours is not concrete, you click on this drop down, and then you can do steel. For steel, you realize I have these universal columns, universal beams, and then I can also change the country where I'm using the members from. And yes, so if you have steel, that is what you will do. And then concrete, we go back to concrete and cancel. Go back to concrete. Now I can change this. I can change it to 400 by 300. Remember when we were starting, there is this idea about materials. So that is where you can go and change these sections. The properties of my sections also come here. But because I don't, I just want to use this one, I can change the section and here and call it 400 by 300 mm. Voila. Wow, just disappeared. And then place it there. You see now it is 400 by 300. And then you also determine the second one. It is at grid number 3A. 3A, place it there. So all these columns are at grid number A. And then they are at number 5. This is 7, 10, 11. 5, 7, 10, 11. And the last one, of course, it was at the end. So there I have my columns. Then I move to have all these. I move to these ones. This is grid number B, or all columns are the same up to grid number 10. So I do the same. Are they in the same direction? Yes, except this first one. I'll show you what we will do. So up to grid number 10 along B. So you can still place them like that. Once it is selected, you can go on clicking at where they are and the model and that. But once, assuming I have escaped and I don't have the command, I can still go back and select my column. You see now, because I had saved the column it brings it automatically. So I can still proceed. Option number 2, if I had escaped, I can double click on the column until it reaches that dialog box. That means I can continue modeling. Without let's finish this line. And then these ones are along grid C. Like that. Now there is something you need to note. Look at the orientation of this column and this column. This column
different.
Yes, the orientation is different. So after modeling, I can change the orientation. I can decide, double click, and then I can decide to do 90 degrees. Date, close. You realize it has been oriented at 90 degrees. But remember that angle was 96.
Is it possible to rotate?
Yes. This angle
Interesting.
here is what you say 96. Update. You see now it is almost parallel to the line. Yes. And then also you note this one, the way it was oriented, let's see. And this one is different. It's this one that is different. So the angle was 97. Enter. Update, and then you close. Realize it comes to that. So I'm done with these ones. Let me proceed. Another column is along grid B. We have a column along 1A, 2, and 4. Grid B. So I double click this. Then I can put it there. There. So this one I need to change the orientation. This is 97 degrees. What about these two? They are okay. Then I also do the external ones along F. Let me do F. That is that. So I need to check the orientation of this. It's okay. Then which other columns? These columns on this side, I have a column along grid 6F.
6, 8, 9,
6E.
6, 8, 9, 10.
11.
Yeah.
6, 8, 9,
11.
Yes. 6, 8. Wow. Just a minute. 8, 9, 11. Then, of course, we have a grid at the end here. 12. Now, you need to be careful because were they on the slabs or on this one? That is what I'm not so sure. The center was on the vertical one. So I delete that. I do it afresh. Center was on the vertical one. So I also need to input these ones, these three. I have a column at grid 9B. You see, you now see the reason why I told you it's good to model them as they are in the layout. You can easily refer once you're modeling them. So 9D, go to 9 and then you go to D, do that there. Is the orientation okay? Yes. Then I have 6E. Go to 6 and then I go to E. Do that there. Now I have one more remaining. The column along grid E8. E8, E8, I have 8, and then I have E. You realize that this column was not of that size. It was 400 millimeter long by 200 millimeter wide. So I need, after putting it, I can start changing it from here. I go to properties. Then it was 400 millimeters long and 200 millimeters wide. Update. But the orientation is not proper. So I do 90 degrees.
90.
Close. Yes. So I have all my columns. Now, the next thing I need to take into consideration is the eccentricity of my columns to the junction of my grid lines. Like in this case, I cannot have columns extending outside my boundary, property boundary. Yes, so I can alter that by moving. I can click on a column, and then I click on the arrows. Then I can move a column. If I'm moving it to the left, to the right, that is what I'll do. It moves by 25.
Which arrow are you using?
The arrows on your how do you call it, on your keyboard.
You see, they won't be that. You remember, it won't be accurate.
Why?
Oh, you are considering the circular point.
Yes.
Okay, that is okay.
And from settings, which I will show you later. I think I can highlight that. When you go to settings, then you go to column and shear wall. There is a place where you can change how far you can move by the arrow. Yes, you can just play around these ones and then you will. Let me see.
There is no problem with that. Let us not go to that.
Yes, with time you can play around and you will find there is a place where you can change the direction.
And you can also move.
How to move?
Hmm?
How far you will move by pressing a single key.
Can you select and remove the 200?
If you have set it like that, but by default it is set at 25 millimeters.
Okay.
That is why it is at the edge. Notice how I am moving it. 1, 2,
Okay.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I move it 16 to get to the other end. That means this dimension was 400. So that means I'm moving by 25 millimeters. So I need to get it to the center. So let me move it 1, 2, 3, 4, 5, 6, 7, 8. It's at the center. And then I need to ensure that it is flashing with a beam. That means it can only extend 100 millimeters outside. Therefore, I can move it up entirely and then I move 100 downwards. That is 4 times. 1, 2, 3, 4. Like that. So you just need to play around this as you do your modeling. There it is. You can also find out how much it's supposed to extend, and these are now things you can do once you have an actual project. Yes. Now we are done with the insertion of columns. If your structure has a shear wall, now you go to wall, and then the properties of the wall are here. You can see for the walls I only have concrete. Then I can say the one dimension is 200, the other dimension is, let's say, 2000. So I can put my wall there, I can start drawing it. No. I've messed up that dimensions. Let's assume I'm using
200 by 800.
Yes, 200. Now for the length, you can only find the length. Here what you define is the section. How can I say it? The height. For instance, let me draw 200 by 500. Yeah. You realize that the length is 6450. But my width is 500. So if I need it to be 200, I can change this. You see, it is now 200 wide, 64 15 meters long. Of course, the height is the height of the floor. So this is how we model a shear wall. But because we don't have a shear wall, we are not going to model. From there, we move to beam. Now you select beam. You do the same thing you did for column. You come here. Then you have that size. You can decide to say I have a 600 mm by 200 mm. and then you come and change this 600 by 200, and then you say okay. Then once you do that, you can now start drawing your beams. See, you just pick the end point and the end point, and you're good to go. As long as your end points are beam axis junctions, the axis intersections. I also remember I had another beam going this way. Now, remember we had a cantilever section. My grid lines end at this location, so I need to have another grid line out here to guide me how far my cantilever is supposed to go. So I need to come here and find out. So this balcony is 1,000 millimeter wide, but from center to center that is 1200. Therefore, I need to offset this by 1200. F2, because it is to the positive side, 1200. Escape. Then there I have my grid line. I want to hide it. So you see it is an hidden line, grid line. Then I select still my beam. Now I can extend it up to that point. You realize that my columns are extending outside the beam, and we said this is a property line. So I have to drag them inside. No, I don't know. Moved something else not supposed to move. Yeah. So these are changes you keep on making from observation and from the information you have. Yeah. So then you can see which other beam I can do. I can do this beam. Where is it ending? Let me see. This beam comes up to here. So do we have this? Let's see now grid lines. We don't have a grid, so we need to have a grid where our beam is going to end. From the center, this is 1600, so it is 1700 up to the center of that. So I need to offset the axis. F2 is to the positive side, 1700, enter. And then properties, I'm going to hide that. Update, close. So I can select from my view. Sorry for that. Select on my beam there. And I model it up to that point. And then what else? Which one? This one, I remember it was coming up to this point. I also remember this one was coming. Yeah. Also, this one was going up to the far end, up to the cantilever, but you realize I don't have my cantilever section here, so I need to offset this. I need to find out how far it's extending. So this is around 1200. So I need to move it out by 1400.
So for that team.
14, because it has to be center to center. And then I'm going to hide it. Update, close. So let me still show you why it is coming to 14. This is 12, huh?
Oh, 13, 14.
Yes.
Okay.
You add 100 here and 100 on the other side. So I have my grid line there. Then do it up to that point. Which other one I need to do? I have this. I have done this drawing before, so I know where most of the columns are going. Most of the beams, sorry. I also have that there.
Is it not country around there?
Yeah. I need to extend this outside. Oh, I have here. Yeah, that one I have forgotten, but still no problem. Now, there are times when you are modeling your beam, it will ask you whether when a beam is crossing another, it will ask you whether you are going to split the beams at this spans, at the supporting spans. Whether you say yes or no, this will not affect the way the structure will be modeled. What will be affected is the labeling of those beams. But it will still model the same. The only difference is that it will give you a beam that has many sections, like beam 1, beam 2, beam 3. All of them are one part of one beam, which is continuous.
Which is okay.
Yes, which is still okay. So I love splitting my beams. So I will say yes, and let's observe this. So you realize that this is 1 beam 31, and this is 1 beam 30, and so on and so forth. But a beam that I did not split, look at a beam like this one. It is 1 beam 6, 1 beam 5, 1 beam 4. So you realize that this beam is also labeled like it is 3. Therefore, it is not going to affect it. And I realized that I was supposed to make this cantilever. Even if I had not continued this beam, I can still proceed like that. So when it will design, it will assume that this beam is continuous. I can also do that there. Yes, let me split. I can also do it here. I can also do it here. What else do I need to do? My mouse wants to behave. So I can do this. Oh, my mouse is misbehaving. Yeah. So for this, I don't know where it's going up to. But which other beam do I need to do? I need to do these ones. So let me do the ones I know first. This. And then here, this external beam, let's find out. You see, it is ending here. Do I have this grid line? I don't. So I have to set
Okay.
it. So this is 1300. So I have to offset it 1500. So that is the number B. Close. So we have it right there. So I'm going to model that. But you remember we had a balcony here. So I can start from modeling from the balcony all the way here. Leave it there. For this one, I can also do the same. Then I had that external beam. So I think I'm done with this point. The only issue I have is here. I can also do this one. And then this one are ending here, so I can also do them. And then now I can also do this. From here, I don't know how it's going. Oh, it's not going to the other end. Now, you realize this beam also comes all the way to the other end. I can also do it. Now, this is the only place that is remaining. I need to do this beam, but I don't have this point, so I need to find it. So let me measure. This is 1000, so I need to set it.
0.1.
Now here I need to do minus because it is to the negative. I love hiding all the grids that I have set. So once I have it there, I can now gladly draw this beam up to that point. Yes. After that, these I have to connect to this end. These also connect to this. Now, this is the only, these two places are the only one. So this connects to that.
There's no need of now putting another one. I think that is okay now.
Yes. So now you realize I have some beams here. These are toilets. I had some beams here. I'm not going to model them because I will design, when I'll be designing the slab, I will design the slab to carry those walls. And because of the spans I'm having a span of around 2 meters by 3.2. So I will have the slab carry those. So I'm not going to design them. Then I also need to, I don't know whether I model this beam. Yeah. So this is where we had the staircase. And now there is one that I need to put, this one. This is 1149, so let me assume it is 1150. That is 1350. And then I still hide it. So I can do that beam. Therefore, I'll get this one also. So I'm done. I think I've modeled all beams. Now, is something I have not done. You realize in the architectural, I have a staircase and then this is a slab. Such that I think, let me observe it. The first floor drawing will explain better. Let's look at the first floor. Yes, you see, I'm having a staircase, but I'm having a slab here for somebody to walk to the balcony. And you also know that for staircases, this beam is not carrying the staircase. And also, the staircase is not being supported from this side. The staircase is normally supported from this side and this side. Therefore, this slab will behave like a cantilever from this shop. So I'm also going to, when I'm doing the slabs, I will model that, but I have to find out where it is ending. And I think it is ending just where we have this beam. Yes, here, where we have it. So I'm good. Therefore, I'm done with the beams. I close. The next thing we do, we are still in modeling, we go to slabs. For me to model slabs, I need to click on slab. And then it opens this dialog box. The slab type, there are 12 different types of slabs, depending on the continuity of the ends. But these ones will not affect my work. There is a way I can just model them and then at the end I will change the type of all the slabs that I create. And then the height, this is the depth of the slab, H. From the spans, doing my preliminary analysis and sizing, I'm going to use a 200 millimeter solid slab. Concrete cover.
Wait, 200.
Sorry?
200 is there's too big in me. Big size.
Yes, the spans are big. I have spans of around, let's measure. I have a span of around, this is 4.7 meters by 6.2. Yes, that is number one. Number two, I have a problem with vibrations. Once, remember these are commercial buildings. And the spans being big, I can design a slab of 150 and it will be sufficient, but it will be vibrating. So the people using it will not be comfortable. Therefore, that calls for me to also remember that these people need to be comfortable while using the structure. Yes, that is why I would prefer 200. And then there is this insertion. Insertion is the method of insertion of your slab. Then there is this drop down arrow. You can either pick axis region, beam region, pick axis, pick points, or pick closed slab edge. When I pick beam region, I click inside a boundary of beams, it draws my slab.
I think that is better.
Yes, so I can proceed and click just inside all of them and then my slab will be drawn. Now. Let's do that. Now, you remember here we had a staircase.
Is another one on the cantilever at the corner.
Remember here we had a staircase. So if I put a slab like that, I'm going to be lying because we don't have a continuous slab. We just have a cantilever slab at this section. So I will still proceed, but I will pick axis region. And then once you click, you realize it will model a slab up to this point, but it will not model this. So I need to change tactic. Then I need to say pick points. Then I can manually pick the points where my slab is going. And it has put my cantilever slab there. So now the next thing is to model my staircase. Yes. For the modeling of the staircase, I because of time and levels, I need to set my levels because the main landing is normally at the A, probably at the center of the building. So I need to change my levels, and it is a bit hectic. So what do I do? A staircase behaves like a one-way spanning slab. So I model a one-way spanning slab, that is a ribbed slab. Then I can work on the parameters and then I model it right there. Oh, let's see. No, not the points. Yeah, can say pick points. Let me pick my points. Though not all staircases you can do this. Yes, you have to examine them carefully. You find out how they are, which beams they are loading. Now you realize these beams are not in the right direction. I need them to face the right direction I want. So you go to insertion and then you change the beam angle to 90 degrees. Update, close. So you realize that now I'm having my staircase loading all this. So to do this is also from experience. To do it, you have to calculate the dead load of your slab and translate it to the loading it can have on a ribbed slab. So here you have to do some manual calculation for you to do this. And then you also input the dead load. So for this, I do not advise somebody who cannot really determine exactly how to do it to go ahead and do it. But I will show you, after we're done modeling, I will show you how to model a staircase. Yes, but for me, I normally do this calculation. I transfer the loading to the dead load of this slab, and then I subject it to variable actions. But though I know it is not entirely accurate, but it gives a result that is almost there about. Yes, because once I have a staircase, it is trying to rotate this beam somehow. Yes, but I will show you how to model that. Yeah, for now, let's just have it like that. So you realize we have done beams, columns, beams, and slabs. Now, for this structure, I did not model solid slabs. I was just doing this to show you. This structure, we designed it using hollow pots. That is it hollow pots? Hollow blocks.
Hollow and ribbed.
Yes, when we see ribbed slabs, between those ribs we have blocks that are hollow.
Yes, hollow blocks. Yes.
Yes. So this is the toilet. So for the toilet, I'm going to leave it solid. Let me then leave this walkway to the toilet as a solid slab. Wow, we wanted to go for 1 hour, but
These are 2 hours.
yes.
So you just insert the.
I'm about to finish.
Yes.
So for you to select ribbed slabs, you come to ribbed slab. And then you set your parameters here. Of course, I'm going to set BW is the width width of my ribs, I'm going to use 150 wide ribs. And then h is the overall height, that is 300. My block size is 400 millimeter wide, and then the height of the top screening is 70 millimeters. Then I change insertion to beam region, and I start inputting. Yes, they are in the right direction. You realize that I have to ensure that my ribs are spanning
in certain direction.
in the shorter direction, yes, because these are one-way spanning. Also, there are a few things you need to consider at this cantilever. You realize that now I'm not going to have my cantilever from the slab. I'm going to have my beams acting as cantilevers. Therefore, they are the ones that will carry the ribs. And if I start tying the ribs in the other direction, it means they are going to load this external beam, which I don't want. So I'm still going to tie them in the direction that the others are running. So when I get here, points. Yes. Oh, need to change this to beam region.
We need to change the other part of the balcony.
Which other part?
On the right hand side.
The right. This one.
Yes.
Why?
And we see how the ribs are rolling.
Now, for this one, the reason why I'm not changing them, I want my slab to be carried by these ribs. The ribs will be extending. They are the ones that will now be carrying the slab.
Okay.
For this side, the reason why I did not do that, if I decide my
Because of the direction.
they are also going to alter the direction.
I've gotten your point.
Yes.
Okay.
But all these things you decide on you can even decide to avoid loading these. You load these ones. So
okay, you hold on there.
Yes. So I have done all the modeling that I needed to do. And now once you're done with this, you go here to slabs. You right click. First of all, you need to ensure you're still within the floor that you're working with. This is floor number 1. You move to slabs where you right click and then you go to set slab types automatically. This is going to set those 12 slab types automatically. Which I showed you that we know how to do them at the end. And then you can just say apply to all slabs in the story. You can just change to all slabs in the model. Okay. It will do that. Then you say okay. For each slab, you can also open the slab table. These are the parameters you have entered. But now I want us to close there so that next time we start working with loadings now.
Okay.
Yes, we do setting of subscripts. There is something called subscripts. But for us to set subscripts, we need to define load cases. That is where we will now come to loading. We will do partition wall loads, we load our beams, and then as we proceed.
Okay.
Yeah. So next time we will do loading, we will load our structure, we will finish the entire model, and we will actually design it.